I am an avatar organized by Dr. Alemi to give this lecture. This lecture is on one-way analysis of variance. Assume that you have observed different values of y for the same value of x, a common situation. The purpose of one-way analysis of variance is to determine whether the means of y values differ significantly across different levels of x values. To do a one-way analysis of variance, first we examine the assumptions, then state the hypothesis, calculate the f-statistic, look up the p-value, and then decide to reject, or fail to reject, the null hypothesis. There are 4 assumptions in analysis of variance. First, that samples are independent. Second, that observations within samples are independent. Third, that the y variable is normally distributed. Last, that population variance is normally distributed. The hypothesis is that all means for the samples are equal. The alternative hypothesis is that at least one mean is different. Test statistic for ANOVA is based on between and within groups sum of squared residuals. We test that the sum of squared residuals for between and within group are not significantly different. Assume we have observations for each case, or each row in the table. The difference of observation and grand average is called residual. The squared residual is summed to get total sum of squares. For between sum of square, we examine the variability for the average of samples and the grand average. Within group sum of squares is calculated as the sum of the observations for each case and the average within the group that the case belongs. The total sum of square residuals can be partitioned to between and within sample sum of squared differences. The f-statistics is calculated as the ratio of the mean of the sum of the squared between and within groups. Means are calculated by dividing the sum of the squares by the degree of freedom. The degrees of freedom between groups is the number of groups minus 1. The degrees of freedom within groups is the number of observations minus number of groups. We reject the hypothesis if the calculated f-statistic is above the same statistic for allowed error rate. Let us look at an example. In this example, we want to know if the patients within 3 hospital wards have the same satisfaction rate. Each patient has independently rated satisfaction with their care. These data show the ratings. We start with group 1 and calculate the sum of squared difference between observations and within group average. The average within this group is 3. And the squared difference from average summed to 20. In the second group, the average is 2. And the sum of squared differences is calculated to be 10. This shows the calculations for the third group. The within group sum of squared residuals is the sum of the 3 calculated value and is equal to 46. To calculate sum of squares between, use the difference of sample and grand average. We did this for the second group. And the last group. The calculated sum of square is 70. The total sum of square is the sum of the squared difference of observed ratings and the grand average. We could have calculated the total as sum of between and within sum of squares. We calculate degree of freedom as the number of estimates minus number of parameters estimated. The mean sum of square for between groups is 70 divided by 2 degrees of freedom. The mean sum of square for within group is 46 divided by 12. The f-statistic is calculated as 9.13. The f-statistic at alpha 0.05 is 3.88. We reject the hypothesis that there are no group differences. This set of slides have shown you how to compare the mean of 3 or more samples from same variable.